Find the spanning tree by DFS method. DFS method is nothing but the depth first search method. So in this method, how to find the spanning tree means, for the given graph, first you choose a arbitrary one vertex. Second, you add the edge incident to it, one of the edge, continuously add the all edges which does not form the cycle, and try to cover all the vertices. What is the difference between previous method and this method means, in the previous method, for the given vertex here, what we did, given vertex here, we added all the edges. For example, A to D, A to G, next to A to E were added. That are level 1 vertices. For level 1, again we are adding. But here not like that. Here what you have to do means, for the vertex A, you can choose a one vertex A. From vertex A, you can add continuously edges. Continuously A to G, G to B, like that you can go. So that we'll discuss here. So now step 1 or 1 solution. Choose vertex. Choose vertex A. You can your choice. You can choose anyone. Second step, add edge to A that incident to A. Only one edge you can add. So add A comma G. So add edge A comma D. Not all edges. You can add only one edge. So these are your chosen A vertex. Next for A, we are adding one edge D. Okay. Next, third step, for D, for vertex D, add edge D comma C. So what will get? A, next D, next D to C. In the third step, what you have to do means, we'll do one thing. If I write that in the new page means, again we need that diagram. It takes time. So in third step, when you come to third step, listen here. A to D, next D to, we do one thing. Already third completed. Fourth, you can just like that, A to D, next D to C completed in the third step. So next what you have to do means, for C you can add. So C, what you can add? You can add edge B. In the next step, you add edge G. Okay. It does not want to form the cycle. Next, for G, you can add edge D. Here E is there now. You can add edge E. Next, for E, you can add edge F. Is it covered all the vertices? Yes, all the vertices are covered. Therefore, it is a required spanning tree. You can go in any manner. You can go G to FER, G to EF, but it does not want to form the cycle. So this I'll say in a one line. This all the thing we'll discuss in the straightforward. When you're doing solution, you have to write like this. For long answer, simply what we will do means, listen here, in the one line, select arbitrary vertex A. Okay. Next, A to D. Okay. Next, D to C. Your choice is going anyway. You can go A to G also, doesn't matter, but does not want to form the cycle, closed loop. A to C. Next, C to B. Next, B to G. Next, G to E. Next, E to F. All vertices are covered, therefore it is a spanning tree. It is a spanning tree. Someone say no, I can go like this in another way. Another way means, for example, A started with A to G. Somebody going A to G, G to D, okay, D to C, okay. Next, C to B, okay. Next, B to E, B to, sorry, C to B, B to E. Next, B to E to F. This is also spanning tree, okay. So, but you don't expect every graph like this continuously. I'll say one example. This DFS is also called as a backtrack method. What is that one means? Find. In this problem, I'll try to explain. DFS is also called backtrack. What is that backtrack? I'll try to show in this example. Find spanning tree by DFS. So now, A, this example you observe carefully. A to B, next G to, everyone adding, almost all added. B to A to B, B to C, okay. Next, this is H, L, next M, okay. Next I, next D, G, J, next M, N, N, next this is a N, N, next M, K, F, P. Okay. For this, you have to find the spanning tree. How to find the spanning tree for this problem? See carefully. Solution by DFS method. Select any vertex. I'm choosing the vertex A. I'm choosing the vertex A. Starting with A. So go A to B. Okay. You have to go like a one path. A to B. Next B to C. Okay. So next C to what is it? C to, I can go H. Okay. Next to H to I. You first to try to cover like this almost all possible vertices. Next to I to D. Next D to E. Next E to F. Next F to K. Next K to J. Next J to, from J to H. Now A to B started with A to B, B to C, C to H, H to I to D, D to E, E to F, K to J, J to H. Is all the vertices are covered? No. So not covered now. So we are started with A to B, B to C, C to H, H to I to D, E to F, E to F, F to K, K to J, J to H. Here J to H completed, but all the vertices are not covered. Sorry, this is N, J to N. So A to B, B to C, C to H, H to I to D, D to E, E to F, F to K to J, J to N. So we stopped at, we got at N. If you N2, if you add any one, it forms the loop cycle. So you don't add here. So, but it all the vertices are not covered. So what you have to do means you go back. You go back and check for J any vertices is there not covered? No. Again go back. For K any vertices is there from the graph to add edge cover vertices? No. Again go back. F. Again go back. E. Is there any vertices not covered? No. Next. Again go back. D. Is not covered any vertices? No. Again go back. Is not covered any vertices? No. Is no. Next, again go back. Is not covered any vertices? Yes. M is not covered. So now here come M. So next, is all vertices covered? No. So what you have to do? Again go back. Okay. Backtrack. This is called backtrack. Again go back. Again go back. See. Is there any vertices not covered? No. Again go back. Is not covered any vertices? Yes. G is not covered. Okay, G is not covered. Next, G to L. So, is all vertices are covered? Yes, all vertices covered. Is any loop? No. Any no loop? No, no cycle. Closed one. There's no any closed thing. Therefore, this is a required spanning tree. Okay. Is there any doubt?
సార్ మనం ఇది ఎమ్ని ఐ నుంచి కూడా కనెక్ట్ చేసుకోవచ్చు కదా సార్?
ఎమ్ని చెప్పండి.
ఐ నుంచి కూడా కనెక్ట్ చేసుకోవచ్చు కదా ఇలా క్రాస్ గా బ్యాక్ ట్రాకింగ్ లో. హెచ్ నుంచి కాకుండా ఐ నుంచి కూడా కనెక్ట్ చేసుకోవచ్చు కదా?
హెచ్ మనకి ఇక్కడ గివెన్ గ్రాఫ్ లో హెచ్ నుంచి ఐ ఆల్రెడీ ఇక్కడ ఉంది కదా, హెచ్ నుంచి ఐ ఉంది. నువ్వు ఎం ఎక్కడ కవర్ అయితే ఎడ్జ్ లేదు కదా, ఎంకి ఎడ్జ్ లేదు కదా, ఉంటే నువ్వు కవర్ చేసుకోవచ్చు. లూప్ ఫామ్ కావద్దు. ఇట్ డస్ నాట్ ఫార్మ్ ద లూప్. లిజన్ హియర్, దిస్ జస్ట్ విత్ ఇన్ 1 minute I revise this one more time. Listen here, DFS method. This you have to write step by step in the your solution. First selected A. Okay, A to B, B to C, C to H, A to B, B to C, C to H. Next H to I, I to D, D to E. Until loop does not form, you have to go like this. E to F. Okay, F to K. Okay, next K to J, J to N. Is all vertices covered? No. So go back. Is there J any vertices? No. No J to I mana kaluputa ante loop అయిపోతది. So now K, no vertices. F, no vertices want to be covered. E, no vertices want to be covered. D, no vertices want to be covered. I, no. Come to H. Yes, H there is vertices missing. So H to M. After writing M, again go back. Again go back. H to C. Next C to B. Is there any vertices want to be covered? Yes, G want to be covered. Next, you can cover L. Okay, this covers all the vertices and no loop. Therefore, this is a required spanning tree. Okay, you not only you can go A to B, you can go A to G also. I started A to B. If you want, you can go A to G also, doesn't matter. For example, somebody say no, I cannot go A to B. If I want to be go from A to G. For example, if anybody say like this, isn't it? For example, someone is saying I started with A, I can go A to G. You can go A to G. Next G to H. If you want here only, one more thing you can do like this. A to G, G to L. Is there any want to be covered? No. Again come back. Okay. Next L to H, H to M. Again come back. Next H to I. Next your choice. You can go I to D, D to E. Okay. Next E to F. next F2 K, next K2 J, J2 N. Is all vertices covered? No. So now go again back. J2 K, K want to be covered? No. F want to be covered? No. E want to be covered? No. D want to be covered? No. No vertices want to be covered. I no. Next come to H. H want to be covered? Yes. H want to be covered one vertex. C. H want to be covered? C. Next, is C want to be covered? Is there any vertices? Yes. B. Is all vertices covered? Yes. This is a spanning tree. So you can go in any manner. You remember that does not form the loops. Does not want to form the loops and want to be cover all the vertices. So now I want to be explain the difference between these two. For example, whatever we did, that one more time I'm doing A to G, okay, next D, next C, next B, next E, okay, D to E, next B, next F, okay, F to G, okay, now, okay, uh, A, C, B, G, F, E, A. So now, first we see the BFS. I'll show the difference between these two. First BFS, what you have to do? Select one vertex, BSF method. Add all the edges that are incident to A. What are there? A to D is there. Next A to E is also there. Sorry. A D to E is there. D, wait a minute. Question. D to G, next A to E. Okay. So now BFS method. First you take vertex A. Okay. After taking vertex A, you add all the edges incident to it. A to D, next A to G, next what is there? A to E. These are called level 1 vertices. Level 1 vertices. Next, what you have to do? You have to do for level 1 vertices, add again all the edges. For D, what is there? C. Next, for D, what is the edge added? C. Next, come to G. For G, what we can add? We can add B. Okay. For E, what we can add? F. We can add. Is all covered? Is all vertices are covered? Yes. Therefore, it is a spanning tree by BFS method. First A vertex, then what we taken? D, G, E, level 1 vertices. Next C, B, F, level 2 vertices. So for this DFS method, what we will do? You select one vertex A. Next, what you will do? A to D, D to C, C to B, B to G, next G to E, E to F. You are going like a continuous path. So that is, if any vertex if any vertex is a missed, you can go backtrack and you have to cover that. That is a DFS method. In the BFS method, what you are doing? One vertex, we are first adding all the edges that are level 1 and the level 2 for the again adding the edges, like that we are covering. Whereas DFS method continuously A to B, A to D, D to C, C to B, G to B, like that we are doing all the thing. If any covered, we are going back. So this is about the today's class. If anyone have the doubt, hello. If anyone have the doubt, you can speak.
Yes.